in this one it says translate the triangle into matrix form. So I just have these vertices 4, 1, 4, 2, and 1, 2. I can write that right here. 4, 1, 4, 2, and 1, 2. And if I multiply this top row, when it's flipped, it's going to flip horizontally and be at 0, 1 when I multiply. 0 times that will ignore it. The 1 will copy that, and when you add them, it's just going to move it up above. So it's going to go 1, 2, 2 up above. Just like this one will take that 1 when it flips, will copy all of these numbers. That 0 will get 0, and when we add each of them, the zeros will not change that top number. So the top number then gets stuck down below. If I go to graph this, I'm going to use green right here. I'm going to go over 1 and up 4, and then over 1, over 2 and up 4, and then over 2 and up 1. And so my graph now is like this. So you can see what's happened is that this thing has been reflected over this y equals x line. That has been reflected over. So I would say this is a reflection over the x equals y line. Now this is one of the tougher ones. On the test it might not be that complicated. It might be simply a reflection over an x or a y axis. It could be scaling, getting larger in one direction or the other. So just tune in to that. The appropriate terminology can be found in the book. That's, translating is when you slide something in the same orientation. Rotation is, as it suggests, reflection is pretty clear. But that's how you would describe that, as a reflection over the x equals y line. Alright, finally it says, suppose a group of young people have a mean height, an average height of 110 centimeters. So these are like third graders with a standard deviation of 8 centimeters. What will be their new mean and standard deviation if 1 year later they have all grown exactly 12 centimeters? Well, that's the symbol for the mean. The x bar is gone from 110 plus 12 to 122. The standard deviation is not going to change because that's all about the spread of the data. So that will still be 8 centimeters. But what will be their new height, their new mean and standard deviation if 10 years later they've all exactly doubled in their height? Well, that's multiplying. So now their average will be twice their original average, so that'll be 220. They've all grown gigantic. They're all NBA players. That's their x bar. And their standard deviation will also have doubled. That spread will now be twice as great, so 16 centimeters. Okay, on to number 5. This is just describing in words. I just wanted you to, again, to come back to the fundamental concepts we've talked about: reflecting, translating, stretching. That negative sign out front reflects over, that's the x-axis, because it takes anything where you're going positive, now flips it and goes negative, but that's the x-axis it's reflecting over. Sometimes that's confusing. This is a little bit of a trick problem, this part here. You need to translate this into a negative sign with x in a parentheses. And you can't just put a parentheses around that, because that would mean that this is negative as well. So you really have to change this to be x minus 3. Think about that. If I bring that negative sign into each of these, I'll get down below. You need to have that x be in parentheses in order to understand the rules of this. And this reflects it over the y-axis. And then this translates plus 3 to right, and this translates plus 7 up. Okay? And I think that's everything. So there you go. Good luck on the test.